Hey everyone, so today we're going to talk about angles in standard position, coterminal angles, and reference angles. So up to this point, we've really only dealt with right triangles and angles that are acute, meaning they're less than 90 degrees. But we know that there are definitely angles that are larger than 90 degrees, so we want to talk about those. So the first thing we're going to define is an angle that is in standard position. So if you have an angle whose vertex sits at the origin in a coordinate plane at the point 0, 0, we say that an angle is in standard position if its initial side lies on the positive x-axis and then it rotates counterclockwise an angle measure, and then its terminal side is that ray extending from the origin where the angle ends. And you guys are usually really familiar with degrees, angle measures in degrees. So if I were to have an angle of 90 degrees, you guys would usually be very comfortable drawing that angle of 90 degrees as this angle right here. 180 degrees would be this angle. 270 degrees would go all the way down to this negative y-axis, and then 360 degrees would have the same initial and terminal side actually, but it would rotate all the way around. And of course you could have even larger angles. For instance, if you went around twice, that would be 360 degrees plus another 360 degrees, which would be 720 degrees. So here in the black, that is a 720 degree angle. But that's what I said, angles in standard position, they start at the initial side, which is the positive x-axis, and they rotate counterclockwise. So what we want to do here is we've got 6 examples, and we're going to draw the angles in standard position. So first what I'm going to do is I'm going to draw some x and y axes for each example, and then we're going to get started. Okay, now we're ready. What I'm going to do down here is I'm going to draw just what I call the 4 corners, just so I can reference them easily. So if I were to have an angle that never rotates, it's just right here on the positive x-axis, that's 0 degrees. If you were to rotate up to the positive y-axis, that's 90 degrees, it ends here. If I were to rotate to the negative x-axis, 180 degrees. Rotate down to the negative y-axis, 270 degrees, and one full rotation would be 360 degrees. So these are just going to help me figure out what quadrant I'm lying in for my terminal side. And let's review quadrants too. So we have quadrant 1, 2, 3, and 4. All right, so here in my first example, I want to draw the angle 240 degrees. So in standard position. So here's my initial side. 240 is going to lie in between 180 and 270, so it will end in quadrant 3, and a little closer to 270, so it's going to be 60 more than the 180. So I'm going to draw that right there. So there's the angle 240. The next one, example 500. So I noticed right off that 500 is greater than 360. So I'm going to go ahead and subtract those two numbers to see how much further I need to go once I bypass that initial rotation. So I'm going to be going around once. That's 360 degrees. And now I need to go 140 degrees more. So that's going to be past the positive y-axis, but not quite to the negative x-axis. I'm going to actually be lacking 40 degrees. So this right here, that piece is 140, meaning there would be 40 left to get to the 180. But the rotation itself, 500 degrees, is here. And I should draw my initial side, and then I've already got my terminal side. All right, the next example is a negative 50. So it's the first time that this negative has popped up. My initial side stays the same, but negative is going to mean that I'm going to now rotate clockwise instead of counterclockwise. So if I were to go 50 degrees, that's going to land me not quite to that 90-degree mark. So this would be the angle negative 50 degrees. So if I were to go down here with negative angles, this would be negative 90 degrees, negative 180 degrees, negative 270 degrees, and then negative 360 degrees in the negative direction. So here in example D, I'm asked to go negative 450 degrees. So again, 450 is larger than 360. So let's figure out how many more I need to go once I go that full rotation. So if I take 450 minus 360, I get exactly 90 degrees. So that means I'm going to land at one of my 4 corners. So let's go ahead and do that first rotation, initial side, 1 full rotation there at 360. Then I need to go 90 more, which lands me right here on the negative y-axis. All right, 540. Again, 540 is larger than 360, so let's go ahead and subtract those. Well, and this works out nice. I have 180 degrees, so I'm landing again on a 4 corner, but I'm rotating in the normal direction counterclockwise. So I've got 360 degrees, and then I got to go 180, which lands me here on the negative x-axis. All right, in the negative 180 degrees, another 4 corner. Here we go. So here are all my angles that are drawn in standard position. Now what we're going to do is we're going to define coterminal angles. So 2 angles whose terminal sides coincide when they're in standard position are called coterminal angles. So these are angles that have the same terminal side once they've been plotted in standard position. So what we want to do is we want to sketch the angle 120 degrees. I want to make this kind of big. So 120 degrees is going to be larger than 90, but not quite to 120. If I were to take to 180, if I take 120 minus 90, so it's going to go 30 degrees beyond 90. So it's landing about right up here. So that would be 120 degrees. And so we want to list 3 angles that are coterminal with 120, meaning they don't have the same rotation, but they do have the same terminal side. So one way to get a coterminal angle is always just to add a rotation in. So if I were to go 360 degrees and then go my 120, that would have the same terminal side. And what would that angle be? Well, I'd start out with 360 and then add 120. So that would be 480 degrees. So 480 degrees is coterminal to 120 degrees. I'm going to color code this. 120 degrees is in the red. In the blue, we've got 480. And now, what if I went around 2 times and then went 120? So I'll do this in green. So I'm going around once, a second time, and then landing here. Well, that would be the 480 that I had in my blue angle. I'm just going to add another rotation in. So if I add the 480 plus the 360, I get 840 degrees. So that would be another coterminal angle. I could continue to add 360 degrees an infinite number of times. And that would give me an infinite number of coterminal angles to the original angle. Now, if I can add 360 degrees or a rotation, I can also subtract a rotation. So go back to that original 120 degrees right here. Initial. If I were to go the opposite direction, so now I'm looking at negative angles. This angle measure right here. Well, you know that one rotation is 360 degrees. So if I were to take 360 minus the 120, I would see that I'm left with 240 degrees. So if I'm looking at this yellow angle here, since I rotated clockwise, that would be negative 240 degrees. And that also shares the same terminal side as 120, so it's coterminal as well. Mathematically, if you wanted to just take 120 minus the 360, you would then have that negative built in for you. And now in the negative direction, you could continue to subtract 360 degrees, where I'm rotating around in the negative direction, and then going out that 240 degrees. We're just going to do one because my spirals are getting pretty long. So I'm going to do this actually in a bold, like a gray color. So here I'm starting here. Let's go around negative 360 degrees and then negative 240. So I'm again starting at that negative 240. I just subtract 360, and that gives me a negative 600 degrees. So there I can continue to subtract. So I can say keep adding or subtracting an infinite number of times to get an infinite number of coterminal angles. Now I want to define a reference angle. So if theta is an angle in standard position, the reference angle for theta is the acute angle, which theta prime is how I like to note it, formed by the terminal side of theta and the x-axis. So on your notes, if you're using mine, it should say is here. Is the acute angle theta prime formed by the terminal side of theta and the x-axis. So this is the really important part. Terminal side to x-axis. Terminal side to x-axis. And acute. Reference angles are acute and positive. So I have a figure to that example actually. So back to our figure up here, because what I want to point out is that all of these angles have the same terminal side, meaning they have the same reference angle. This right here would be my reference angle, right here. And that reference angle will always be 60 degrees for the reference angle. I'm going to put RA for the reference angle so that we don't get that confused later on. So 120, 480, 840, negative 240, negative 600. They all are coterminal and they all have the same reference angle of 60 degrees. Remember, reference angle is terminal side to x-axis. Here, that I think is really helpful. So if your terminal side lands in quadrant 1, the first quadrant, the reference angle is just equal to the original angle because you're always going terminal side to x-axis. So this is my reference angle right here. So the reference angle will just be the original angle. Now let's say that the terminal side lands in quadrant 2. If the terminal side lands in quadrant 2 and you go terminal side to x-axis, this little piece right here is the reference angle. Notice it's always terminal side to x-axis. Reference angles are always acute and they're always positive. In the second quadrant, it's always how much more do you need to get to 180? Like how much more do you need? Now if your terminal side lands in quadrant 3, terminal side to x-axis is giving me this angle right here. And it's always how much more is there from 180? Like what's the overlap? And then if your terminal side is pushed into the fourth quadrant, then you're asking how much more do you need to get to 360? So notice these reference angles, terminal side to x-axis. And let's look at some examples. So here in the first one, I'm asked for a reference angle for 120 degrees. So first let's plot 120 degrees in standard position. So here's my initial side, and then 120 degrees is going to lie in the second quadrant. So the reference angle is terminal side to x-axis. This right here is the reference angle. So if this is 120 degrees and I know 180 degrees is where I'm looking at going, I see my reference angle is 60 degrees because that's how much more I would need. So reference angle is 60 degrees, or sometimes theta prime is 60 degrees for 120 degrees. Now in the last example, when we were looking at coterminal angles, remember there's an infinite number of coterminal angles for every angle. We did this example of 120 and we saw, I think we had 4 or 5 listed, but there's an infinite number of coterminal angles. But there's only one reference angle. And I'm going to go back. All right, let's look at number B, or letter B, negative 57 degrees. So let's first start by plotting negative 57 degrees. Now, 57 in and of itself is an acute angle, and the negative means I'm rotating clockwise. So when I go negative 57 degrees, I land here in the 4th quadrant. Now when I'm looking at, I actually kind of want to draw that in blue just to be consistent. So there's negative 57 degrees. Reference angle is terminal side to x-axis, right here. So when I go terminal side to x-axis, I notice that the reference angle here is just 57 degrees. It's just the positive angle measure. All right, next let's do E and F, and I'm going to actually go ahead and change those to C and D because I got rid of, I thought 6 examples was a little much for one slide, so I changed it. All right, I want to go ahead and do negative 215 degrees. So let's start with my positive and negative x and y axes, my initial side. Now negative 215, so 215 is larger than 180, so I know that I'm going 180 degrees, and then I'm pushing past that 180 degrees, but I'm not quite getting up to the 270, so it's going to land about right here. And now when I go and find the reference angle, I'm going terminal side to x-axis, and now I need to actually calculate that. So if I take 215 and I subtract out that 180 degrees, the overlap there is 35 degrees. So this reference angle is positive 35 degrees. Notice that all the reference angles are acute and they are all positive. All right, the last one, 480 degrees. So 480, I notice, is larger than one rotation, so let's take 480 minus 360. Put that in the wrong place. And I notice that I have 120 degrees left. All right, so now I'm noticing that letter A and letter D, these are coterminal angles. Now it's time to graph this. So initial side, I go through one rotation of 360, and then I go 120 degrees more. So my terminal side to x-axis is my reference angle right here. And when I look at the math on that, since I went 120 degrees, I need 60 more degrees to get to 180. So there's my reference angle. And I already kind of spoiled that earlier when I went back to that example. Since these two are coterminal, 120 and 480 are coterminal, they have the same reference angle. So now what I want you to do is pause the video. I've got 4 examples here for you to try on your own. My advice is to draw them in standard position first and then calculate the reference angle. And whenever you're done, you can unpause the video and come back to check your answers. Okay, welcome back. So hopefully you can check your answers for A, B, C, and D, and you feel good about 1, drawing the angles in standard position, and 2, finding those reference angles. So if you need to pause the video now and check your answers, please do so, because I do want to discuss one more thing before I set you free to do that problem set. So the thing that we had said on the last slide is that coterminal angles have the same reference angle. And this is true. Coterminal angles will have the same reference angle. But I want to know if the opposite is true. So I'm looking at A and D right now. So A and D, 260 degrees and negative 800 degrees, they both have a reference angle of 80 degrees. But notice they are not coterminal angles. So while this statement that I've drawn in this cloud here is true, the reverse of that statement is not true. If you have two angles that have the same reference angle, that doesn't necessarily mean they're coterminal, because those terminal sides could lie in different quadrants. They do have a relationship, though, which we will explore more in the coming lessons in 3, 5, 6, and 7. When we do the unit circle, you're going to see that they do have a relationship, though. And so now you guys are all free and ready to do that problem set.